Heat Kit Educational Systems, in cooperation with the Electronic Industries Association, welcome you to this videotape presentation. This video is part of a series of new generation Heat Kit Educational Systems videos designed for individual or small group presentation. Possible that the 20th century will be recorded in history as the age of electronics. It began with the invention of the vacuum tube in 1902. Within 20 years, an electronics industry developed, and the principal product was the radio. This new industry created the need for service personnel. Then, as now, the removal and replacement of components by soldering was a necessary skill. The course of electronics was altered by the invention of the transistor in 1948. Consumer products became smaller, consumed less power, and portable devices became common. By 1960, the technology for fabricating circuits in a small package was revealed. These integrated circuits, as they were known, opened the door for the miniaturization of electronic products. By the last decade of the 20th century, space-age knowledge and advancements in integrated circuitry led to consumer electronic products of increased complexity and shrinking size. They became smaller and smaller. As you can see, the history of electronics is an evolution of miniaturization. Manufacturing techniques have improved, and products have become more reliable. We can expect this trend to continue, and with it, greater challenges for the service technician. The removal and replacement of components by soldering is an essential skill for electronic technicians. This training video has been prepared to help you develop soldering skills that are necessary in today's world. It is divided into two parts to accommodate both the beginner and advanced student. Before we start, you should know that electrostatic discharge can damage sensitive electronic components. You may be familiar with static electricity and know that it develops by friction, by normal movement such as walking across a carpet. An electrostatic charge of several thousand volts can accumulate on a person's body. Electrostatic discharge, or ESD, occurs when the charged body touches a point of lesser potential, such as a circuit board. A static discharge of 3,000 volts is barely noticeable to most people. However, failures to sensitive circuit devices have been documented after an exposure to electrostatic voltages as low as 200 volts. Although electrostatic discharge can instantly ruin components, damaging effects are not always apparent, and failures can occur at some future point in time. There are several methods that prevent damage by electrostatic discharge. First, you can use a grounded conductive mat with a wrist strap in the work area. If a mat is not available, drain off any electrostatic charge on your body by touching a known earth ground immediately before handling the static-sensitive component. Second, use only a grounded tip soldering iron. Next, use only anti-static type solder removal devices. And finally, use only self-propelled chemical sprays that are classified as anti-static. Do not remove a replacement electrostatic sensitive component from its protective packaging until you are ready to install it. At that time, touch the protective package to the conductive mat. Then, remove the component. To reduce the possibility of electrostatic buildup on your body, avoid unnecessary bodily movement while handling the component. After removing an assembly containing electrostatic sensitive components, place the assembly on a conductive surface. Now, let's turn our attention to the tools and materials necessary for soldering. The first item to consider is the solder. There is a wide assortment of wire solder available. Therefore, we will only point out those properties necessary for high-technology soldering. The first property is size. In general, wire solder with a diameter of 25 thousandths of an inch is appropriate. This size may be referred to as 23 gauge. The second property is flux. Flux is a material that cleans and prepares metal surfaces that are to be joined together by soldering. The recommended flux for electronic soldering is rosin flux. It is non-corrosive and electrically non-conductive. The core of most wire solders is filled with flux. Use only those solders with rosin core flux. The third property is the tin to lead ratio. Solder containing 63% tin and 37% lead has the lowest melting temperature of any solder. This quality makes this type of solder suitable for miniature electronic soldering. A cleaner or flux remover is necessary to remove flux residue after a soldering operation. Although the soldering flux is non-corrosive, it is sticky and will attract dust and dirt which may present future problems. In addition, the cleaning makes it easier to inspect your work for flaws and greatly improves the appearance of the finished job. Let's now turn our attention to the tools necessary for soldering. The most important tool will be the soldering iron. Regardless of the type of iron you select, a major consideration is that the tip be grounded to prevent damage from electrostatic discharge. Less expensive soldering irons suitable for high-technology soldering are the butane pen and the pencil iron. The wattage rating should be in the range of 15 to 50 watts. For most irons of these types, the tips may be changed for various soldering applications. A better quality soldering iron is found in the self-contained soldering stations. Although expensive, most soldering stations are temperature controlled. When the desired temperature is selected, sensors and control circuitry maintain the tip at the set temperature. The cost of the station may be justified by increased servicing speed and a reduction in damage to circuit boards and components due to excessive temperature. The tools you will need are quite simple. They include pliers, tweezers, a dental pick, a brush for cleaning. And remember, safety glasses or goggles are extremely important for eye protection. A holding device for small circuit boards will be of considerable help in the soldering process. With it, the circuit board can be positioned at a desirable angle for soldering. An illuminated magnifying glass is necessary for precision work. Before we can demonstrate soldering techniques, it is necessary to first remove the existing components. This is done by desoldering. There are a variety of tools designed for the removal of solder during the desoldering operation. Solder wick, vacuum bulb, vacuum plunger, and heat and suction. We'll see each one demonstrated in the next few minutes. Okay, it's time to go to work. Be sure that you work in a well-ventilated area and avoid breathing fumes. The first step in any operation involving the soldering iron is to clean and tin the iron tip with a coat of solder. This process may be called tinning and is necessary for the maximum transfer of heat. The desoldering braid is a composition of small copper wires braided together. It is manufactured in several sizes. Select the size that will cover the joint but not interfere with adjacent pads and traces. Place a well-tinned iron tip on the braid. The tip should be large enough to cover the braid and joint without touching adjacent pads. When the braid becomes hot enough to melt the solder will be drawn or sucked into it. Use the braid to remove the solder from each pad. Continue this process until the solder is removed from all pads. When all the legs are free, turn the board over and remove the component. Another simple method for removing solder is by suction. It involves the soldering iron and either the suction bulb or the hand vacuum pump. These devices are often called solder suckers. To remove a resistor with the suction bulb, first press the soldering iron tip against the resistor lead and pad. Squeeze the bulb to create a vacuum. Then place the Teflon tip against the heated connection. When the solder melts, release the bulb and the molten solder will be sucked into the bulb. If necessary, use the dental pick to free the resistor leads. Desoldering with a hand pump is much the same as the vacuum bulb method. Arm the vacuum pump by pressing the plunger down. Place the soldering iron tip against the transistor lead and pad. Place the Teflon tip against the heated connection. When the solder melts, release the plunger and the molten solder will be sucked into the pump. Remove the solder from the other leads in the same manner. Other methods for removing solder by heat and suction involve the use of self-contained desoldering tools, like this simple soldering iron with an attached suction bulb. The tip of the desoldering tool should have an inside diameter slightly larger than the lead or pin to be desoldered. Squeeze the bulb to create a vacuum. Place the tip over the pin to be desoldered and press down with a gentle rotating motion. When the solder melts, release the bulb and the solder will be drawn into the bulb. Eject the vacuum solder from the bulb after each extraction. There are more sophisticated desoldering tools that operate on the same heat and suction method. This commercial station, for example, has vacuum and temperature controls to provide more efficiency. The technician has already selected a tip for the iron with an inside diameter slightly larger than the lead or pin to be desoldered. Adjust the temperature and vacuum according to the manufacturer's instructions for the type and size of the component. Typically, larger components will require more heat and suction to remove the larger amounts of solder. Place the tip of the iron over the lead to be desoldered and gently press down with a rotating motion. The molten solder will be rapidly and efficiently removed. As you can see, the removal of solder by this method leaves the connections very clean. For efficiency and speed, this system is difficult to beat. In most cases, the IC can be removed from the board without additional work. Now that we have removed the defective IC, we can replace it with a new one. Regardless of the method used to remove an IC or transistor, the replacement process will be the same. The first step in the replacement process is to thoroughly clean the foil side of the board of excess solder. With desoldering braid and a clean iron tip, wick the excess solder from each pad. Use the magnifying glass to inspect the pads and traces for solder bridges or other flaws. A solder bridge is an unintentional connection between two pads with solder. Turn the board over and install the new component. Make sure the pins are straight and that the IC is properly oriented. Gently insert the IC and press it firmly into place. One secret of good soldering is to keep the iron tip clean and well tinned. Place the tip of the iron so that heat is applied to both the IC lead and pad. Next, touch the solder to the heated junction until the solder melts and flows around the IC pin and pad. First, remove the solder, then the soldering iron. It is recommended that this operation be completed in 3 seconds or less to prevent damage to the component. Continue this process until all of the pins are soldered. Use the magnifying glass and dental pick to check for solder bridges and loose connections. If a bridge is discovered, remove it with the solder wick. Spray the area with flux cleaner and brush it to remove the flux residue. Perform a final inspection with the magnifying glass. The board should look like new. Other components, such as transistors, are replaced in a similar manner. As with the IC, the first step is to clean the circuit board pads of excess solder. Inspect the board with the magnifying glass for damage. Bend the transistor leads in the same shape as the original. Insert the transistor and slightly bend the leads in back to keep the component in place. Place the tip of the iron against the transistor lead and circuit board pad. Touch the joint with solder until the solder melts and flows around the connection. Remove the solder first, then the soldering iron. Again, this operation should be completed within 3 seconds. Make the remaining 2 connections in the same manner, then clip the excess leads. Clean the board and perform a final inspection. This completes part 1 of the Electronic Soldering Techniques program. You were introduced to electrostatic discharge and the steps you can take to prevent damage to sensitive components by proper grounding techniques. You were shown simple solder removal techniques that include desoldering braid, suction bulb, hand vacuum pump, and heat suction. A more efficient method involved the use of a commercial vacuum and heat station. Practice the methods you learned in part 1 of this video. Then proceed to the advanced soldering methods shown in part 2. You are well on your way to becoming a first-class electronics technician. Stop the tape here and